In this video, we want to evaluate the integral of ln of the square root of x plus 1. And I've done several similar to this. So just in case you haven't seen one like it, I'll go ahead and do the whole setup. It does involve integration by parts. And what I'll do first, I'll rewrite it this way. So this is the integral. Now keep in mind that this is, when you have the square root of x plus 1, that's the same thing as x plus 1 taken to the 1/2 power. So I can rewrite this here in the integrand as x plus 1 to the 1/2 power. And there's a property of logs that allows you to bring that exponent out in front of the log. So this becomes the natural log. So I don't have the radical or the exponent now, it's just x plus 1. Put that in parentheses. And then this will be to the 1/2 power here, but it comes, I can put it out in front of the log, and because it's a constant, I can bring it outside the integral and write it here. This is dx, another way to write that. Okay, so now, just looking at this part right here, I'm going to select my u, and of course, that's the part I'm going to differentiate, and then select my dv, and that's the one I'm going to integrate. So I'm going to differentiate the natural log because it's easy to do that. So I'm going to let u equal to ln of x plus 1. So then du will equal to the derivative of natural log of x plus 1, which would just be 1 over x plus 1. And then it's times the derivative using the chain rule. Derivative of x plus 1 is 1. So that'll stay a 1 there, and then it's dx. And then my dv, what else do we have here? Looking over here, you can always create a 1, or 1 dx. And then antiderivative, or integrate here, derivative of dv with respect to v, give me v. The derivative of, say, 1 dx is x. We don't need a constant here. We'll do it at the final answer. And now we can follow through the process. So the process for the integration by parts is you multiply the u and the v. So here's my u there, and there's the v. Doesn't matter what order you put them in. I'm going to put the v first, so instead of uv, I would write vu. So I put the x here, and then the u. So it's ln of x plus 1. So now I'm integrating this expression right here. So the 1/2 is going to stay out in front. And then everything gets multiplied by the 1/2. So I'm just going to put this is equal to, and then I'm going to have the 1/2 out in front. That's this 1/2 right here, which comes from the radical. So I got a 1/2 multiplies everything in here. This is the first part of this integral over here, ln of x plus 1. And then it has a minus the integral of, and then it's v, which is x, so this will be x here. And then it's multiplied by du. And du is this right here. So I put 1 over x plus 1 dx. And then I just multiply here by x and integrate. And what I'm going to do is I'm going to do a division here. Right, this is x over x plus 1, and then long division. So this will be x divided by x plus 1. So I go then, x goes into x1, put the 1 there and multiply the dividend times the divisor. So 1 times x plus 1 is x plus 1. And then we subtract here. This x minus x cancels, and then 0 minus 1 is minus 1. So the answer to this division is 1, and then minus 1 over the x plus 1. So the remainder over the divisor. So let me rewrite this then. This is going to equal to 1 over x, or 1 over 2, 1/2. And the first part stays the same. So I'm going to rewrite it. X, ln of x plus 1. Okay, so right in here then, I'm going to have, in place of this right here, I'm going to put it on the side here. I'm going to have 1 minus 1 over x plus 1. And I got the dx right here. Okay, so all I'm doing is rewriting this part right here. So it's the integral, and I'm going to put this minus here. Again, this all in brackets, I'm multiplying by 1/2. So this antiderivative, or the integral of 1 with respect to x, is x. And I got a minus, and then you have a minus here, so that's going to give me a plus. So it's going to be plus 1 over x plus 1. So the integral of 1 over x plus 1 is just going to be plus the natural log of x plus 1. Now, since I used the property on logs and brought this 1/2 in front, I didn't put absolute values in there. So I'm going to assume that we're okay and just work it that way. This is what we got so far. Then we've got the constant of integration. Now this is actually the answer. 1/2 multiplies all of this. X, ln of x plus 1 minus x plus ln of x plus 1. But what I'm going to do here, again, I got the 1/2 there, so I'm going to keep in mind I could call this the answer right here. All the integrals have been computed here. But in some textbooks they'll rewrite this and simplify it. So let me do this. Notice here I have a ln of x plus 1, and then here I have a ln of x plus 1, and I got everything multiplied by 1/2. So I'll still put the brackets here, and I'm going to factor out the ln of x plus 1. If I take out the ln of x plus 1, I still have an x here, x, and I take out the other one, ln of x plus 1, I get a 1. So if I factor that out, what do I have left here? There, x plus 1, because I factored out the ln of x plus 1. And then this is multiplied by the x plus 1. So I'm going to write this as x plus 1. Now, so it's clear to you, the x plus 1, or this x plus 1 here, is not contained this way. So I actually could put this out in front. But what I'll do is I'll write it this way. I put another brackets here, just so it's clear to you that that expression is multiplied by x plus 1. And then the only thing I have left here then is the minus x, plus the constant of integration. And then this is going to equal to, now I'm going to distribute the 1/2. So I'm going to say, okay, multiply this natural log here by 1/2. And then because we started off with a radical, I'm going to bring this 1/2 to this parentheses. So this will be natural log x plus 1 to the 1/2. So that'll give me the same thing as ln, and I'll write it as a radical, square root of x plus 1. And I've got this minus x here times the 1/2 also. So I'll write this as minus x. Well, wait a minute. I've got my factor here. I still got this x plus 1 here. So let me write it here. See, this is then x times x plus 1. Again, these are just multiplied here. The natural log of square root of x plus 1 is multiplied by x plus 1. So I could put this out in front if it confuses you here now, since I've already used the 1/2. And then I have minus x multiplied by 1/2, so this will give me minus x over 2 plus the constant of integration. This is your answer if you want to simplify it. So again, just to make it clear to you, I'll write it this way. So I put a brackets on this side here and a brackets over here. So this reads in natural log of x, natural log of the square root of x plus, and that's a 1, not a 2. So again, it's the natural log of the square root of x plus 1 multiplied by a factor of x plus 1 minus x over 2 plus the constant of integration. Okay, so this again is your more simplified answer, but this answer here is also accepted. At least I would accept it. Thanks for watching. We'll see you next time.